Today's day is gonna be the 22nd day of doing grinding LeetCode. This is a series of video where I try to find a LeetCode easy problem to solve within 15 minutes. If I can't solve within 15 minutes, then I'm gonna try to look at the solution and solve it. So let's get started. The first section is already done. This SQL grind. So let's do the LeetCode algorithm question. I'm just trying to find myself an easy question here. Hopefully on the first try, so I won't have to refresh this page 20 times. Let's see, algorithm question, and I'm gonna refresh it, pick one. No. At some point, I'm gonna switch to C++ to do this algorithm question. 2 out of 3. Let's see. Given an integer array, num1, num2, num3, return a distinct array containing all the value that are present in at least two out of the 3 array. You may return any value, the value in any order. So 1, 2, 3. What the hell? The value are present in at least 2 array are 3 and 2 in num. Okay. Am I just making 3 set out of this thing? No value is present in at least 2 array. Okay. Okay, whether A is going to be very easy or B is going to be very tricky. So, if I'm looking at this value, is it inside of 2 and 3? What is the most efficient way I can do this? If I just throw everything inside a set, right? A set will contain distinct value, but it would not contain undistinct value. If I union 3 and 2, that's going to give me 3 and 2, which is the result. If I union 3 and 1 and 2 and 3, 3 is a distinct value. If I union num 2 and 3, then that's going to give me 2 as a distinct value. And if I union 3 and 1, that's going to give me 1 as a distinct value. So the condition states, so I have to do 2 for loops here, don't I? But what is a more efficient way of doing this? What is a more efficient way of doing this? Because I can just do like 3 for loops and have it does that. But I want to do this in linear time. How can I do this in linear time? So we're going to do a union of num1 and num3, right? That's going to be the first set. Then we're going to do a union of num1 and 3 and num1 and 2. Num1 and 2 and num2 and 3 and num3 and 2 and 3 and 1. Set of this is some crazy math, isn't it? This is some crazy math. Yeah, and this is one of IJK. IJK can be up to 100. The length of it can be up to 100, so that's very slow if I do bigger one. How can I do this in linear time? Well, I can just put everything inside of a set, like say num1 and num2, and then take out the number of num1, see if it's in the num2. There is a number inside of num2, and add that to the result, right to the result, and then I can go loop through num2, take out the number of num2, compare that with number in num3. If num2 number is in num3, then add it to the result, and then I can take num3 number and then look at num1 number. Look at the number inside num1, which is 3 for loop, and then see if that's any of it is in there. Then it's gonna be add that to there. That's gonna be a linear time. But what can I do better? That's gonna be the easiest solution. What can I do better? I can throw everything inside of a set, right? And then check to see if the one number is in at least 2 of the set. So if num1 is in num2 and num2 is in num3, that's going to be one giant for loop checking to see with a whole bunch of conditional. But it's not going to be faster. Yeah, I'm just gonna do three for loop. I'm just gonna do three separate for loop here. So first thing I'm gonna do, num1 set is equal to num1 set of num1, num2, num3, and this is 3. So for n in num1, 1, if n in num2 res equal to an empty array, let's just assume that there is no edge case and this is the best case scenario. For n in n, if n in num2, then we're going to do res plus res.append pen n. Cool, that's the first one. Now for n in num2, if n in num3 res.append n. For n in num3, if n in num1 res.append n. And we just return res here. Duh. Num1 is not defined. You kidding me? Nums. Nums. Alright, I can run this 3 more times. And then I will not run it anymore. Because otherwise I'll be running this a million times and not get it. What? Output 32233. Oh, wait a minute. So I have to so that had to be a set, not that set. Because a number can already exist. That's a good point. Res.add n. Add n. Return res list of res. Run that sucker. Oof, that's low. Yeah. If S1 and S2 and S3, if all three of them, or S1 and S2, if this is union all three, S1 and S2, S2 and S3, and S1 S2, 3. Return S1 and S2. I did not know you can do that. At least 2 or 3. S1 and S2. What is this doing? This is making sure that it's inside all three of them. So let's try that actually. This is really slow. So res S1 is equal to set of nums1. Now we're going to do it again here. 3, 2, 2, and 3. Now print out, return S1 and S2. No, just print out S1, S2 first. Print out S1 and S2 and S2. Return an empty array for now. Run that sucker. So this will give me all the number instead of S1 and S2. It's going to give me this. But it's expecting a list. How do you convert it to a list? 2 and 3. S1, S2 with an OR operator, right? So what happened if I OR this with the it's giving me a set as a result. If I OR this with S2 and S3, or this sucker, see what I got. 2 and 3. What about the second case? Third case. S3 out, S1, S2. So num1 and num2. No number in 1, 1 is in num2. S3, num1 and num2. Number no num1, num2 is empty. Yeah. So S to the out 3 and 1 because 3 is in both of them. So 3 is here. And 2 is in here and here. So that's 2 here. What if I do one more time? S3 and S1. What if I just return that? Does the condition say to return anything that's at least in all three array? Oh, well, I mean, if you think about it, if number one is in S2, I mean, one union two, one, no, not exclusive, one union exclusive, what is it called? Union and the opposite, intersection. Union and intersect. Yeah, if one intersect, it's like discrete math intersect three circle. Yeah, here. So if A intersect B, which means it's here, right? If A intersects B and B intersects C, which means it's here, if C intersects A, which means it's here. So all three of them, if you intersect all three of them, that means what is the opposite of that? If you what is it called? Boolean algebra? No. In math, there's a theory. In math, there is a theory that inverse exclusive. De Morgan's law. De Morgan's law. There we go. Image. De Morgan's law, a union and intersect. Yeah. If A union B is uh so this is an OR, right? This is an OR gate. So OR, so that's the same as this is S1 and S2. This is an OR gate, right? Okay, so if we do a not here, not this, which means this is gonna be OR. This is gonna be converted from, it's the same thing as doing, oh God, what's the law that simplify? Boolean algebra. What is the law that simplify? Boolean algebra. Uh, associate commutative. That's fine. De Morgan's law. Absorption. A plus AB. Okay, we can probably dig into this a little more here because we can pull out an S1. This is an OR operator. This is just ORing it, all of them. Hmm. This is an OR operator. So we want to change this to an AND. If S1, if a number exists in S1 and S2, if this number exists in S1 and S2, then give me this, and it's going to AND. So the not, the opposite of that is going to be AND, AND, or, or, or. So, so if this number exists in S1 or S2 and S2 or S3, which means we can get rid of this two condition. We can get rid of one of them. If this number exists in S3 or S3 and S3 or S1, so which means we can get rid of S3 and oh no, this is an AND. No. Let's go back a little bit more. If this number exists in S2, so that S2 is redundant, we can just get rid of this, which means S1 is here. If this number is exists in S2, but S3 is right here, we can get rid of S3 because we're redundant and cramming it. It is OS1, we already checked for S1, so we can delete that. I don't know, I'm just making up my own math rule here. Anyways, have good days, have good life, goodbye.